Hello everyone, welcome back to my channel. Today we'll be looking at the sources and collection of data. The outline we have here will be sources of data, sampling techniques, methods of data collection. Today we'll look at the major sources of data and different sampling techniques, but we won't be able to go deeper into all the sampling techniques today. We'll just look at two of the sampling techniques, and in the next class we'll be looking at other types of sampling techniques and the methods of data collection. Sources of data. We have two major types of sources of data, two major sources of data. We have the ad hoc collection, which is normally known as primary source of data, and we have the routine, which is commonly known as secondary source of data. Primary source of data, these are special collections usually derived from data collected from the routine source. Is just like a data that is drawn from its original source. They are used for the specific purpose for which they were collected. Example of a primary data is like special survey, epidemiological surveys, the Nigeria Demographic Health Surveys. We have fertility survey, also experiments in terms of clinical trials, therapeutical trials, prophylactic trials, risk factors for various health conditions, community trials. Primary source of data are data that probably you design your own question and collect your data from the subject. The subject here can be participants in terms of human being or animal. So primary source of data are the one collected from its original source for your own specific purpose for which the data were collected. Then we have the regular or secondary data. Regular or secondary data are generated data used for some purposes other than that for which they were collected. These are established system of data collection. It has the problems of timeliness, bias, incompleteness, relevance, representativeness, inaccuracy. Secondary source of data are something like census, vital registration system, hospital records, schools, disease notification register. So it's just as if I'm interested in looking at the number of diabetes patients in a particular hospital. Secondary data is when I go to the hospital to retrieve the hospital records, because the record initially was not for my own purpose, was not for the number of diabetes patients which I want to work on. So when I go to the hospital to retrieve that record, is now termed as secondary data. Also our census that we do, we can use the census, the National Population Census Commission, whereby we have census every 5 or 10 years in our country, in different country. We can use that to generate our own data. From there you can easily retrieve the people that are in low socioeconomic settings, the people that are in rural area of a particular country. Those are secondary data. Then we have sampling. What is sampling? What is a sample? I remember in this channel we've talked about sample and population before, whereby we said sample is just a fractional part of the whole population. A whole population that you are interested in studying, but you don't have the capacity to study the whole population. You just take a fractional part of it. That is what is called sample. Then that will lead us to sampling. Sampling is just the process of selecting the sample. That is the process of selecting a number of individuals for a study in such a way that the individuals represent the larger group from which they were selected. So sampling is just the process of taking that fractional part of the population, which is the sample, is the process of selecting the number of individuals for a study. And you ensure that when you are selecting the individual undergoing that process, you must ensure that the individuals represent the larger group from which they were selected. We have different methods of selecting sampling units from sampling frame. So why are we doing sample? Why not the whole population? Like I said the other time, it takes a whole lot, like it takes a lot of resources in terms of time, money, and workload. And why sample as well? It gives results with known accuracy that can be calculated mathematically. When you don't sample, it takes too long a time to cover the whole study population. There may be inaccuracy. In a situation where you are saying you plan to, and it's not probably on the national level or something funded, and you say you want to look at the risk factors of people that have malaria in the whole Nigeria or in a particular country, it will be a whole lot. Why not look at some states in the country whereby you can use this to generalize the whole population in the country? That is sample. In the course of saying you want to study the whole population, there might be inaccuracy. Fatigue will set in from those that are helping you with the data collection in terms of maybe research assistant. Even you yourself, you might be tired, and at the end of the day you have inaccuracy, incompleteness, and it makes possible the study of a large heterogeneous population. Sample allows the study of a large heterogeneous population. Then it ensure high speed of data collection. And we sample because when it is impossible to study the whole population. Say you want to study the whole population of a country that is like 50 million. There are like 50 million in total. It will take a lot of time and a lot of effort. So we sample when it is impossible to study the whole population. We have two major types of sampling techniques. We have the probability samples and we have the non-probability samples. So we'll first look at the probability samples, whereby we have different types. We have simple random sampling, systematic sampling, stratified sampling, cluster sampling. And we also have non-probability sample. Method of selecting random samples, which is known as probability sampling. This probability sampling are the best methods to achieve a representative sample because you do it with intentionality. You just don't do it anyhow, like the way it's convenient for you, but there is a process, there is a procedure that you follow for you to be able to ensure that the sample you are picking is a true representative of the whole population. So we have common techniques, just like I mentioned the other time. We have the random sampling, we have the systematic, we have the stratified random, and we have the cluster. The simple random sampling, just from the word simple, that means it's something that is very easy to do. It's not something that is that complex. So simple random sampling is a method of selecting subjects so that all members of a population have an equal and independent chance of being selected. So when it comes to simple random sampling, level of biasness is minimal because everybody has an equal chance of being selected. The advantages of simple random sampling we have is they are easy to conduct and everybody has equal chance of selection. That's why we have equitable method of selection, and it has high probability of achieving a representative of the sample. It meets assumptions of many statistical procedures. No matter the advantages, definitely there will be disadvantages. So the disadvantages are identification of all members of the population can be difficult. When you want to use simple random sampling, you must identify all the members of the population which you are interested in taking their sampling, and this might be difficult, inappropriate for large population. In a situation where we have so many large population, we have population of, let's say, 5 million, and you say you want to do simple random sampling of maybe your sample size is 5,000. How do you intend to achieve that? So very inappropriate for large population. Minority subgroups of interest in population may not be present in sample. So those that are minority in that group of the population you are interested in, you might find it difficult for them to be represented in the sample. So let's look at the selection process of the simple random sampling. Number one thing you need to do when you want to use simple random sampling as your probability sampling technique, you must identify and define the population, such as I want to look at fibroid among women of reproductive age in Nigeria. I'm making use of Nigeria because I'm from Nigeria. So identify the population. I've been able to identify my population that they are women of reproductive age, and I've given them the definition. Women of reproductive age, if they have fibroid or not, those are the people I'm interested in. Then determine the desired sample size. If I say women of reproductive age in Ibadan, Nigeria, how many sample size? What is my sample size? Let's say I intend to use 1,000 of them. How do I intend to get this 1,000 of them? Is it that I'll just go to every houses and be asking, do you have any women of reproductive age? No. I have to probably go to the hospital. Then how do I intend to achieve this hospital? We have so many hospitals. Ibadan is a very big city. We have so many hospitals in Ibadan. So you now need to list all members of the population. So I already know that primary health care facilities, secondary facilities and tertiary facilities in Ibadan, we have women that goes there that are of reproductive age. So I need to list all those facilities so that I'll be able to get the members of my population. Then assign all members on the list a consecutive number. So I will ensure that I assign, okay, I want to, at the end of the day, I try to reduce the hospital that I want to use into 4. How do I intend to achieve that? That means 250 in each of the hospital. By that, I'll be able to achieve my desired sample size, which is 1,000. Then you now assign all members on the list a consecutive number. Then you now use table of random number or lottery system. Most times we have all this computer software that can help us to generate numbers. So with this number, you use it to determine which units are to be selected from the whole population. So that's simple random sampling. We have here systematic sampling. We'll stop at systematic sampling today. Then in our next class we'll proceed with the stratified sampling. Just from the word systematic, that means it follows a system. It's systematic in nature. It relies on arranging the target population according to some orderly scheme and then selecting elements at regular intervals through that ordered list. Excuse me. So when you want to use systematic sampling, that means the target population must have been arranged according to order, and you now select those that you need from the list according to how they've been arranged. It will involve a random start initially, and then you proceed with the selection of every case element from then onwards. In this case, in a situation whereby the population size is 10,000 and I have my sample size to be 100, so how do I get my K? That will be 10,000 divided by 100. From there, I'll be able to get my K. Let's say my sample size is 1,000, population size is 100,000, is 10,000. 10,000 divided by 100, that means 10. So that means if I want to pick from the target population, I'll pick every 10th person. That will be the individual that I'll pick for my sample. It is important that the starting point is not automatically the first in the list, but instead randomly chosen from within the first to the kth elements in the list. So, if I say, okay, I'll pick the first person, the first individual on the list, that might introduce biasness. So instead of saying the first person is the first person automatically, you have to randomly choose from within 1 to 10, since our case is 10, from within 1 to 10, you have to choose the first person, then you now select every 10th person from the target population. Example is selecting every 10th name from the telephone directory, and every 10th sample also refers to as sampling with a skip of 10. Let's look at some advantages of systematic sampling. Samples are easy to select. A suitable sampling frame can be identified easily. Sample evenly spread over entire reference population. What are the disadvantages? Sample may be biased if the periodicity in population coincide with that of selection. Some members of the population don't have an equal chance of being included. Since you already said the Kate number, just like the example with the 10th person. So every 10th person, so that means everybody does not have the equal chance of being included. And it's very difficult to assess precision of estimates from such a survey. So this is the end to our class today. Next class, just like I said, we'll look at stratified and cluster sampling as type of probability sampling, and we'll look at other types of non-probability sampling. Till then, please ensure you subscribe to this channel if you are yet to subscribe to this channel, and you can as well like and share with others. If you want to reach out to me, you can reach out to me. If you want to learn more than this, you can reach out to me on the number that is on this channel. Thank you. Bye.